By late 2025, something extraordinary is happening in our solar system. 7 sizable comets are set to converge in the inner solar system within just 6 months. Among these icy wanderers is 3IATLAS, only the 3rd interstellar comet ever discovered, a visitor from beyond our solar system. The timing of this event is incredibly unusual. Normally, surveys detect just 2 or 3 bright comets over a half-year period, but this cluster pushes the boundaries of probability. Astronomers estimate the odds of 7 significant comets appearing in such a short span are less than 0.5%, making this a once-in-a-lifetime occurrence. This rare celestial alignment will create a kind of cometary traffic jam, with multiple objects moving through the same region of space in quick succession. It is not just the number of comets that is fascinating, but also their diversity. Some will remain faint and hard to spot, while others promise spectacular displays visible to the naked eye. Scientists and skywatchers alike are preparing for an unprecedented season, carefully tracking each object as it makes its journey toward perihelion, the closest point to the Sun, where these icy bodies will erupt with gas and dust, creating glowing comas and dramatic tails. The arrival of 7 comets in such a short span has never been documented in the modern digital era, and even historical photographic records show few comparable events. Whether this is a coincidence, the result of unusual gravitational nudges in the outer solar system, or something even more mysterious, the 2025 comet season is shaping up to be one of the most exciting astronomical events of the decade. Tracking comets has come a long way from the days of patiently scanning the night sky with the naked eye or small telescopes. Today, astronomers rely on highly sophisticated automated surveys like Pan-STARRS and ATLAS. These networks of telescopes are strategically located on remote mountaintops in Hawaii, Chile, and South Africa, giving them some of the clearest and darkest skies on Earth. Every 2 to 3 nights, these observatories sweep nearly the entire sky, capturing faint glimmers of light that would escape even the sharpest human observer. Their cameras are incredibly sensitive, able to detect objects far dimmer than Pluto ever appears from Earth. Each observation produces millions of pixels filled with stars, galaxies, and other celestial objects. The real challenge is detecting subtle movements from frame to frame, tiny shifts in pixels that indicate the presence of a new comet moving across the background of the cosmos. Once an automated system flags a potential comet, a chain reaction begins. Alerts are sent out instantly to observatories worldwide. Telescopes swing into action to confirm the discovery, sometimes within hours. This real-time coordination has transformed comet hunting into a high-speed scientific race. What once took months of patient observation can now be detected, tracked, and analyzed almost immediately. The result is a dramatic increase in discoveries, allowing astronomers to monitor even the faintest and most distant visitors as they make their journey through the solar system. In 2025, these advanced detection systems will be pushed to their limits. With 7 significant comets arriving in such a compressed time frame, even the most powerful automated networks will be overwhelmed, generating more alerts than ever before. For astronomers, this is both a challenge and an unprecedented opportunity to study multiple comets in real time, each revealing new secrets about the mechanics of cometary behavior and the dynamic processes of our solar system. The 2025 comet season is not just remarkable for the sheer number of comets, it is extraordinary from a statistical perspective. In a typical 6-month period, astronomers expect to see 2 or 3 comets bright enough to capture the attention of observers, whether amateur stargazers or professionals using powerful telescopes. The rest tend to be faint, distant objects that barely make it into the minor planet center archives. But in 2025, the solar system is breaking all the usual rules. 7 significant comets will arrive within a single half-year. When researchers run Monte Carlo simulations and population models for comet activity, the results show this cluster is an extreme outlier. Statistically, the probability of seeing 7 major comets in such a short span is less than 0.5%. Some simulations even suggest this could be a once-in-a-thousand-year event, a true cosmic anomaly that challenges our understanding of comet dynamics. This statistical rarity has astronomers and survey operators glued to their monitors. Normally, detection pipelines can handle the data load easily, but this compressed schedule means alerts and images are pouring in faster than ever before. Every discovery must be confirmed, tracked, and analyzed in real time, leaving little room for error. It's a 6-month cosmic lottery where the odds of encountering multiple bright, spectacular comets all at once are staggeringly low. For observers and scientists alike, this anomaly transforms 2025 into more than just a year of comet watching. It becomes a rare laboratory for understanding the behavior of these icy wanderers, their orbits, activity levels, and interactions with the Sun. This unusual clustering provides a once-in-a-lifetime chance to witness, record, and study a phenomenon that may never occur again in our lifetimes. Before diving deeper into the excitement of the 2025 comet season, it helps to understand some fundamental concepts about comets. The first key term is perihelion, which simply means the closest point a comet comes to the Sun. This is when the comet experiences the most intense sunlight, causing frozen ices on its surface to vaporize and release gas and dust, forming the glowing coma and tail that make comets so spectacular. Essentially, perihelion is the moment when the comet puts on its main show. Next is magnitude, which astronomers use to describe brightness. It can be a little counterintuitive. The lower the number, the brighter the object. A magnitude of 6 is roughly the faintest star visible to the unaided eye under ideal dark skies. Magnitudes of 3 or 2 indicate a comet so bright it can rival the brightest stars in the night sky, and some comets can even outshine the planets. Understanding this scale helps you know whether a comet will be a subtle telescope-only object or a dazzling display visible to everyone. Finally, let's talk about comet tails. Comets typically develop at least one tail, sometimes two, as they approach the Sun. The dust tail is broad and often pale or golden, made of tiny grains pushed away by sunlight, fanning out along the comet's orbital path. The ion tail, in contrast, is thin, straight, and blue, formed from charged gas molecules swept directly by the solar wind. These two tails tell different stories about the forces acting on the comet, from sunlight to space weather events like solar storms. Occasionally, a solar storm can even snap the ion tail off, creating a dramatic tail disconnection event. Knowing these basics will help viewers decode every upcoming comet headline and chart, recognize what they are seeing in the sky, and appreciate the subtle interplay between a comet and the Sun's influence. In 2025, understanding perihelion, magnitude, and tail types will turn casual observers into informed witnesses of a rare celestial spectacle. Not all comets in the 2025 lineup will steal the spotlight. Some are subtle travelers, barely noticeable against the starry background. Two of these quieter visitors are C222 Pan-stars and 240P Neat. Pan-stars will reach perihelion far from Earth, beyond Mars' orbit, where sunlight is too weak to trigger a dramatic display. Its coma will be modest, and most casual observers won't see more than a faint smudge even through a telescope. 240P Neat is slightly closer, but still distant enough that its glow remains subdued, making it primarily a target for dedicated amateur astronomers who patiently track and stack images to capture its presence. These comets remind us that the 2025 season spans the full spectrum, from subtle cosmic whispers to headline-grabbing showpieces. On the other hand, 3 comets in 2025 promise true visual spectacle: Swan, Atlas K1, and Lemon. Swan, officially C2025R2, will pass just a quarter of an astronomical unit from Earth in late October, close enough for even casual sky watchers to see it at dawn. Outgassing will produce a bright greenish coma and a dramatic tail, potentially reaching magnitude 2 or 3, rivaling the brightest stars. Atlas K1 will dive deep inside Mercury's orbit, where intense sunlight will trigger explosive jets of gas and dust. Its tail could stretch across the sky, producing unpredictable outbursts that make for breathtaking photos. Lemon, C 2025A6, will make its closest approach in early November, drifting into dusk skies with enough brightness to be visible to the naked eye in rural areas or through binoculars in towns. This contrast between quiet and spectacular visitors makes the 2025 comet season uniquely diverse. Some comets will reward the patient, detail-oriented observer, while others will offer a dazzling show for anyone willing to step outside at the right time. The stage is set for a rare combination of subtle science and unforgettable spectacle, providing something for every type of skywatcher. Some of the 2025 comets will make impressively close passes through the inner solar system, offering skywatchers an opportunity to witness them in all their glory. Swan, officially designated C 2025R2, will make its closest approach to Earth on October 21st, coming within just 0.25 astronomical units, about 37 million kilometers. This proximity means sunlight will interact strongly with the comet's icy surface, creating a vibrant green coma and a dramatic tail that could be bright enough for casual observers to see with the naked eye, especially under dark skies at dawn. Atlas K1, another highlight of the season, will reach perihelion on October 8th, plunging inside Mercury's orbit. At just 0.33 astronomical units from the Sun, intense solar radiation is expected to supercharge its activity. Powerful jets of gas and dust will erupt from the comet, forming long tails and unpredictable outbursts, perfect for telescope imaging or astrophotography. The sheer intensity of sunlight at this distance will make Atlas K1 a dynamic and ever-changing spectacle as it barrels through the inner solar system. Lemon, designated C 2025A6, will make its closest approach on November 8th, drifting into evening skies after sunset. Its projected brightness, potentially magnitude 3.5 to 4, makes it visible to the unaided eye in rural areas, while binoculars will reveal more structure in the coma and the beginnings of its tail. Lemon's evening appearance allows more people to experience a comet without having to rise early, giving the season a second window of dazzling visual displays. These close approaches create a rare sequence of opportunities for observers around the world. From Swan at dawn to Atlas K1 solar orbit fireworks, to Lemon in the evening sky, the 2025 comet season offers multiple chances to witness these celestial visitors at their peak brightness, each with its own unique personality and spectacle. Not all comets in 2025 will be easily visible from Earth. Some, like 414P Stereo, pass so close to the Sun that sunlight overwhelms them from our vantage point, making them nearly invisible to ground-based telescopes. This is where space-based observatories play a critical role. Missions such as SOHO, Solar and Heliospheric Observatory, and Stereo, Solar Terrestrial Relations Observatory, are designed to monitor the Sun, its corona and the solar wind, but they double as comet hunters, capturing detailed images of objects that would otherwise remain hidden. These spacecraft provide unique perspectives on comet behavior, especially phenomena that are difficult or impossible to observe from Earth. One dramatic example is tail disconnection events. When a comet's ion tail encounters a coronal mass ejection, an eruption of charged particles from the Sun, the tail can be severed in a matter of minutes. SOHO and Stereo have captured such events in stunning detail, revealing the powerful interactions between comets and solar activity. Observers can watch as a comet's ion tail is ripped away, leaving a temporary tailless coma before a new tail forms, giving insight into the dynamic nature of space weather. During the 2025 comet season, these space-based instruments will work in tandem with ground-based telescopes to create a complete picture of the inner solar system. While some comets dazzle observers on Earth with visible tails and green comas, others remain a scientific treasure, visible only through spacecraft eyes. These observations help researchers understand not just the comets themselves, but also the invisible forces at work in the solar system, the solar wind, magnetic fields, and the interactions that shape the tails of these icy visitors. By combining Earth-based and space-based perspectives, astronomers will track all 7 comets in unprecedented detail, making 2025 a landmark year for both visual spectacle and scientific discovery. Among the 7 comets in 2025, none is more extraordinary than 3IATLAS, the third interstellar comet ever detected. Unlike comets originating from our own solar system, this visitor comes from beyond the Sun, carrying chemical signatures formed around another star. Observations from the Hubble Space Telescope, the James Webb Space Telescope, and ground-based observatories have measured its coma, the cloud of gas and dust surrounding the nucleus, at nearly 700,000 kilometers across. To put that in perspective, the coma is nearly half the diameter of the Sun and more than 50 times wider than Jupiter, dwarfing the tiny rocky core at its center. Even more remarkable is 3IATLAS's chemical composition. While most comets are dominated by water vapor, this interstellar traveler exhibits a ratio of carbon dioxide to water of 8:1, creating a vivid green coma and driving extreme outgassing. Jets of gas and dust erupt continuously from the nucleus, carving arcs and streamers in the coma that shift with its rotation. Fine grains are expelled at about 6 kilograms per second, while larger chunks may reach 60 kilograms per second. Imagine the weight of a bowling ball being launched every second. For astronomers, 3IATLAS represents a once-in-a-lifetime opportunity to study the chemistry and physics of a comet from another star system in real time. Its massive dynamic coma and active jets allow scientists to observe processes of outgassing, tail formation, and interaction with solar wind like never before. Every new image, every spectroscopic measurement adds to our understanding of what materials exist beyond our solar system and how they behave under sunlight and space weather conditions. This interstellar visitor is more than a spectacle. It is a portal into another part of the galaxy, offering clues about planetary formation and the diversity of materials in the cosmos. Watching 3IATLAS is like observing a comet made in a different stellar nursery, a rare scientific window into worlds beyond our Sun. While 3IATLAS itself poses no threat to Earth, its journey through the inner solar system may leave a lasting legacy in the form of a dust trail. N-body simulations suggest that some of the tiny particles ejected from the comet's CO2-rich jets could intersect Earth's orbit in mid-2026. This presents an unprecedented opportunity for scientists to study material that originated around another star, grains of dust that have traveled light years across interstellar space before entering our solar system. Meteor. Scientists are already preparing for this rare event, planning radar observations and airborne campaigns to detect and collect even a single interstellar dust grain as it burns up in Earth's atmosphere. If successful, these grains could provide direct measurements of isotopic ratios, chemical composition, and other properties completely untouched by our own solar system. Such data would be a groundbreaking window into the formation conditions of planets and comets around other stars, offering a chance to compare interstellar materials with the familiar substances in our cosmic neighborhood. Importantly, while the dust may pass through Earth's vicinity, the simulations confirm that there is no collision risk from the comet itself. The event is purely observational, a scientific treasure hunt rather than a hazard. For astronomers and planetary scientists, every piece of dust captured represents a new data point, a tiny messenger from another star system delivering secrets about its origin. The 2025-2026 Comet season, led by 3IATLAS, is not only a visual spectacle but also a rare experiment in interstellar chemistry and planetary science, offering insights that could reshape our understanding of how other star systems form and evolve. Despite the dramatic headlines and social media buzz, all 7 comets of the 2025 season follow carefully calculated paths, and none poses any risk of colliding with Earth. Professional astronomers using the world's largest telescopes, along with global databases maintained by the Minor Planet Center, have confirmed that these icy visitors will pass safely at vast distances, with the closest approach, Comet Swan, still 37 million kilometers away. This means the 2025 Comet Parade is a spectacular visual event, not a hazard. For casual sky watchers, timing and location make all the difference. Swan, reaching its closest approach on October 21st, will be visible low in the eastern sky just before sunrise. Under dark, unobstructed skies, it could shine as bright as magnitude 2 or 3, rivaling the brightest stars. A small telescope or even a pair of binoculars can reveal details in the coma and the emerging tail, though the naked eye may catch the main spectacle. Later in the year, Lemon, C 2025A6, slides into the western evening sky from November 6 through 12, offering a more accessible viewing window without the need to wake up early. Its predicted brightness, magnitude 4, potentially brighter, makes it visible to the unaided eye in rural areas, while binoculars enhance the view, revealing subtle features in the tail and coma. Observers are encouraged to dress for the weather, find a wide, unobstructed horizon, and give their eyes time to adjust to the darkness. Patience is key, as comet brightness can fluctuate and views change nightly. A printed star map, a phone app, or a simple compass can help locate the comets, turning this rare celestial convergence into a memorable experience. The 2025 Comet season offers something for everyone, from casual dawn and dusk watchers to amateur astronomers with telescopes. All can safely enjoy the rare sight of multiple comets threading through the inner solar system, a cosmic show that has no known precedent in over a century of observations.